Hello, in this video I'm going to go over a past paper question for Further Stats OCR A 2021, a non-parametric test, and the question actually tells us it's Wilcoxon, but we've got two Wilcoxon tests, so we have to decide which one. So that's the first thing, and we also got to basically carry out the test, and there's a few other questions with it as well. Let's look at the question. It's about actually the opinions of ratings of school lunches in a particular school. And 8 pupils are asked to rate the scoring for a school lunch before a new menu is introduced. And we want to see if there's actually been a change as a result of this menu, if there's enough evidence to support this at a certain significance level to support the fact that it's actually changed as a result of this new menu. Okay, so let's set up the hypothesis first, and then we can actually talk about which test it is. So the hypothesis is H0, we can just say, I'm going to use symbols here, MA equals to, well, let's call it MB, you'll see why in a moment, equals to MA, is my null hypothesis. There's no difference between the population medians before or after the new menu was introduced. H1 MB is not equal to MA. Now it's two-tailed because of the word changed here. That's what makes it two-tailed. Now you might think it's what some people get a bit mixed up with. They're saying, well, look, clearly, because it looks like they've increased, and we're testing whether there's a significant increase, because you might think that is intuitively so, but that's not how hypothesis tests work. When we do a hypothesis test, before collecting the data, we decide whether it's a two-tailed or one-tailed test. Okay, so we don't kind of predict that, sometimes if we think that they might be increased, then we might have justification for making it one-tailed. But generally, if in doubt, we go for two-tailed and then see from the data, whether there's enough evidence to support that. So basically, that's why, in this case, although it's increased, we weren't necessarily to know that before the data was collected. And because we've made the decision we're going to test for a change before data is collected, it's a two-tailed test. Okay, so we don't retrospectively say, oh, well, look, it's an increase, so therefore we're going to make it one-tailed, which is actually quite dodgy statistics and relatively controversial because, of course, it's easier, in inverted commas, it's, to actually kind of get something significant from a one-tailed test than a two-tailed test. So, but that's bad stats. We decide before if it's one-tailed or two-tailed, we justify, and then we collect the data. So the fact that they're increased here is neither here nor there. As far as we're concerned, in exam questions, it's all in the wording of the question. So if you've got the word increase, decrease, or whatever, which suggests it's one-tailed, then you go with that. Whereas here, from the wording, it's clear it's two-tailed. Okay, so it's two-tailed test, not equal to. Right, now I need to define what I mean by MB and MA, where MB and MA are the population medians of scores before and after new menu is introduced. Respectively, because before, so MB that's why MB before MA after. Okay, so that's my hypothesis. There's 2 marks for that. They did expect the word population in the mark scheme here, whereas it doesn't always do that. Well, the reason why they have done here is it's clear what we mean by the population. The population is finite. It's a set of all students and all pupils in the school, and we've taken a sample. So it's appropriate to use the word population, and it was expected to get both marks. Okay, so now let's actually turn to actually doing the test. What we do is we rank them in order. Now, we rank them, and it's arbitrary whether we go from smallest to highest or highest to lowest, or whether we go increasing or decreasing. I tend to go increasing, so the smallest is 0, the next smallest is 1, and we get the next smallest is 2, the third smallest, then 4, then 5, then we've got a 6, a 7, an 8, 9 there, 10, 11, then 12, 13, 14, 15, 16. Okay, so now we need to, it's actually given in the formula book what to do. It says make M the smallest sample set. Now, I should say this is going to be a Wilcoxon rank sum test. I haven't actually discussed that yet, I don't believe. Why is it a Wilcoxon rank sum test rather than a signed rank test? Well, it's clear because of the word different that that we're dealing with unpaired data here. So that's why it's Wilcoxon rank sum test. Okay, so it's a Wilcoxon rank sum test. Here it's perhaps a little bit more, you have to be even more careful to check which test it is, because if we were to have a different number, say if there was a 16 there, then we would know it was a Wilcoxon rank sum test more obviously because we've got different numbers in each set. But here we have to look more carefully to check it's unpaired, which makes it Wilcoxon rank sum test. Otherwise, in this instance, we would use the Wilcoxon paired signed rank test if it were paired. There's actually a question about that later on. Okay, so we're doing Wilcoxon rank sum test because it's unpaired data. Right, so there's a number. So we've got looking at the numbers here, what's in the formula book, we've got M and N here. M is the smallest. Now here we don't have a smallest, they're both the same. So it doesn't matter which one we decide to be RM. We could use that one as RM or this one as RM. It makes no difference. It will all come out in the wash through the process. I'm going to pick the smaller set, these values as my values for RM here. So let's do that. RM equals to 1 plus 2 plus 3 plus 4 plus 5 plus 9. That's 24 plus 10. That's 34 plus 11. That's 45. Now it's clear that this will be the number that we're going to, this is going to be our test statistic rather than this. It's fairly clear, but I think it's important to follow the process anyway. But this will be our test statistic because we can see that these numbers are bigger. So I'm clear, but we better follow the process anyway. So let's work out the alternative for it, which would be 8. And then 8 and 8 plus 8 plus 1 minus 45. And that comes to 91. So our test statistic equals to 45. It's a test statistic. W equals to 45, which is our test statistic because it's the smallest. and say it was patently obvious. In this case, because they're the same numbers in each set, if you added these together, they'd be 91. But I think it's best to not try and be too smart with these things. You've got to play the game and follow the algorithm. So the smallest is smallest, and that's our test statistic. Okay, so that's our test statistic. Now we need to actually look in the tables. We've got 8 by 8, and we've got, it's clear it's two-tailed, 5%, two-tailed at 5%, and we've got 8 and 8, 49. So that actually, we can actually say that's less than the critical value, which is our critical value. You see, if you like, this is our test statistic here. And this is our critical value from tables. And it is described, I mean, we should intuitively know whether that means whether we reject or not, but it is described in what to do. For each values of R and M, the largest value of W, which will lead to the rejection of the null hypothesis. So 49 is the largest that would lead to the rejection of the null hypothesis. So, for example, 50 would not. But we're actually even smaller than 49, so 49 will reject it, or anything smaller. So the conclusion is reject H0. So we say there is sufficient evidence, and we need context and some level of uncertainty, nothing too definitive. There is sufficient evidence to suggest there is sufficient evidence to suggest the ratings of pupils have changed. We need context as well, as a result of the new menu. Okay, so I probably better put the word median in there, the median ratings of pupils have changed as a result of the new menu. Okay, so that's the hypothesis test done, 8 marks for that. So just make sure you follow the process properly, make sure you define everything and set it out, and it should be 8 marks to the good. Okay, so the next part is, now this is all about what happens if you were to, we were to pair them. So in other words, if these did, if these were the same from the same pupil. Okay, now the answer here is it takes out, why would we, in that case it would be a better test. And because it takes out an important element of uncertainty here, because what it does is it takes out the differences between pupils' tastes. So it takes out uncertainty involved with having different students who may have different tastes. or words to that effect. Now they did not accept it's a more powerful test. It will probably be a better, more powerful test, but that's kind of more, that's not really what they're looking for here. It actually takes out that level of uncertainty that we have. Because, for example, you might, if you chose 2 different 8-1s, you might, 2 different sets of students, as was done, you might end up having a particularly fussy set of students for 1 8 just by chance, and you might have a less fussy for the other 8. Whereas if you've got the same one, that level of uncertainty is taken out. Okay, so then finally, well, it's not finally. There's a couple more marks, a couple of more things to come up. The next thing, it says, state which test should be used if the students follow this test is followed. So here we would say that any paired test, e.g., and I would say paired Wilcoxon rank sum test, not rank sum test, signed rank test, would be better. But the key thing is, because notice I've mentioned the word paired, but it actually in the question here, it doesn't talk about, the word paired is not used. It describes what paired is, but to have asked the same 8 pupils both times, it doesn't use the word paired. So they're looking for a paired test really here. So if you just said Wilcoxon signed rank test, that wouldn't get it. But paired, any paired test, or any paired test would actually get the mark on this. So now on to the bit of a curveball that they like to do as a kind of to really keep us on our toes for the final bit. The question says you are given that there are 1, 2, 8, 7, 0 ways in which 8 different integers can be chosen from integers 1 to 16. Estimate the number of ways of selecting 8 different digits between 1 and 16 inclusive that have a sum less than or equal to the critical value used in part A. Sounds like a load of gobbledygook, but it isn't really. What they're getting at here is the whole idea of the null hypothesis assumes that there's no difference between them. So any kind of differences in the scores from one group to the other just through random variation. That's how the null hypothesis, that's how we set up the null hypothesis. So if you think about it, well, first, before I talk about it, the 1, 2, 8, 7, 0, they're actually trying to help us with that, but it wouldn't be difficult to get that number. That's just 16C8, which is 1, 2, 8, 7, 0. Okay, so if they wanted to make it a bit more, even more of a curveball, but maybe they just find it easier to word the question by actually giving us that answer. So basically, how are these critical values actually coming about? Well, imagine that they were randomly scattered. It was just random. I'm going to explain a little bit of how it works and talk around the question a little bit more, because hopefully then that will kind of make a bit more sense. So if they're random, assume in H naught different, then we could get 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 just randomly, and that actually equals to 36. So that's the smallest they could be. Okay, or we could have 9 plus 10 plus 11 plus 12 plus 13 plus 14 plus 15 plus 16. That's the largest they could be, which would be equal to 100. So if they were random, so you could just by chance have 8 that are actually smaller than one, where that you actually pick 8 smaller ones randomly, and the other one just for sheer chance, or the opposite way around. So the way it works is that 36 is the smallest the number could be. Our critical value, however, is 49. Okay, so 36 goes like this. Our critical value is 49, so it's going to go up towards, we've got all these up towards it, 49. That's our those are our critical values. But then, of course, any other values we can get 50, 51, so on, up until the number halfway in between these two, which would be our median, which is 68. And then on the other tail, we would have 100 being the largest that we could get, 99, 98, and so on, up until this number, the equivalent one now, which would be 13 less than that, which I think would be 87. Okay, so these would be our kind of critical values either side on a two-tailed test. So this would be 2.5%, and this would be 2.5%. So randomly, we need to have it so that 2.5% of the numbers would be less than 49, and 2.5% of the numbers would be greater than 87. I'm just saying this just for information. We don't need that for the calculation. But the total number of combinations, as what I've already said, is, and it's given in the question, is 12870. Times by, now that's the total number, but we want 2.5% of them to happen randomly by 2.5% of the time. So that's times by 0.025. Okay, and if we times those two together, 12870 times by 0.025, that's 321.75. So it's either going to be 321 or 322. I'll just round it, 322. So that's our answer, approximately 322 different combinations. So we could just randomly get one of those. That's how the null hypothesis works. There is always a chance that you kind of just randomly actually get a surprisingly difference between the two. But 2.5% is the threshold here, 5% two-tailed. So of the total number of combinations, for all of them, all of these together would be 12870. So we want approximately 2.5% of them to be less than that critical value 49. Bit of a difficult one to unpick, that question. I suppose the only thing to say is it's only 2 marks, and thank goodness, because I think it'd be quite confusing. It might be a little bit confusing, and I hope that this explanation has helped in some way. Okay, but the main thing is that we know how to actually do the test. We know the difference between Wilcoxon signed rank test and paired and the Wilcoxon rank sum test. Okay, that's it. Goodbye.